Okay, hi there. I was tutoring one of my GCSE Higher students yesterday online, and I taught her proportionality a couple of weeks ago, and she came across a question which she struggled with. It was a past paper from Edexcel, notoriously difficult exam board, and they have a tendency of twisting questions. So this is a good example of that. So what we're told is y is inversely proportional to d squared. D is 10 is and y is 4. That's fairly standard. We're also told there's a second variable which connects d, and we're told d is connected to x squared, directly proportional to x squared. And we're also told that x is 2 and d is 24. But what the question actually asks is create a formula which connects y and x directly. So what we have here is two equations with a connecting variable d. So what we need to do is deal with them one at a time. So I'm going to deal with the first one, and obviously I'll deal with the second one afterwards. But first of all, we're told that y is inversely proportional to d squared. So for number one, our standard notation, y proportionality, often called the fish, proportional to d squared, inversely proportional to d squared, so that's 1 over d squared. Okay, and then we can go ahead and get rid of the proportionality sign and multiply by a constant. We'll just call that k. Okay, so the first thing to do obviously is to work out the value of k. Nothing unusual so far. So all we need to do is sub in our values. So I know that d is equal to 10 and y is equal to 4. So we can sub both of those into our relationship. So we know that 4 is equal to k upon 10 squared, which is 100. So therefore k is equal to 100 times 4, 400. So we can go ahead and write our relationship between y and d squared. Y equals 400 over d squared. Okay, so that's the first one dealt with. We're going to move on to the second one now. So now we're moving on to the second part, which is the connection of d being directly proportional to x squared. So once again, we can say d is directly proportional, so there's no inverse here, to x squared, or d equals kx squared. It's not the same constant, but we're just going to use the same notation for k. Now we just need to substitute our values of x equals 2, d equals 24. So we therefore know that we're going to do here, sorry, x equals 2, d equals 24. Okay, in the same way, we're going to plug in 24 into d, and we're going to do k multiplied by x squared, which is going to be 4. Okay, so from this relationship, dividing through by 4, we get k is equal to 24 over 4, which is equal to 6. And then we can go ahead and write our relationship. D equals, from this relationship here, 6x squared. So we've found out two relationships, y in terms of d and d in terms of x. But what we're actually asked to find is y in terms of x. So that is a little bit sort of awkward because we've got a variable that connects these two via d. So what I'm going to do is I'm going to literally substitute d in place of our d squared in our first relationship. Okay, so we're going to simply say that d squared, I'm going to square this, square 6, 36, x to the 4, and then replace d squared in my original relationship, y equals 400 over 36, x to the 4. So there's an almost finished solution. We're asked to simplify it or put it in its simplest terms. Looking at our two numbers 400 and 36, they both have common factors of 4. So I can rewrite that by dividing top and bottom by 4. Get 100 over 9x to the 4. And there is our final solution. Quite a challenging question because this was got a standard, and then of course there was the little twist which Edexcel have a tendency to do. So I hope that was helpful, and I'll catch up soon.